While reading the entire file in one go is very easy, often it's more convenient to read it one line at a time, if nothing else because you may want to perform some processing. For instance, in the case of a FASTA file, we may want to separate the header of the protein from the sequence, and we may want to assemble the lines of sequence into a string. So let's have a look at how that can be done. Here we again open our FASTA file for reading, and the first line of the file, we have it here. The first line of the file is the header, so we can read that single line and store it into a variable called header. Then the sequence is slightly more complicated because first of all it's split among several lines, and then we don't know how many of these lines we're going to have. And finally, you see that each line, including the header line here, is actually terminated by a \n. That's a new line character that is not visible, but that causes basically the line to wrap into a new line. So clearly, when we assemble all these lines into a protein sequence, we want to remove those \n's because they are not amino acids. So to start with, let us define a string, an empty string, into which we're going to build a sequence. And this is going to be a kind of string accumulator. If you want, we're going to add one line at a time of sequence to that string. Then we can use a while loop, and this is a while true. And we do that because we don't quite know when we will have to exit this loop. In fact, we'll have to exit it when the file is over, when we have read all the lines. So within the loop, the first thing we do is we read one line of the file, and then we check. Now, if all the lines have been read, readline will return an empty string, pretty much like readlines returned an empty list. And so we check. If LL is an empty string, that means that we have read all the file and we can actually exit our loop. Otherwise, we will have read one line of sequence. So what we do is we take away the trailing \n from that string, and then we concatenate it to the sequence that we've built so far. So we concatenate it to the protein variable. And then we loop again until we reach the last line, in which case, after the last line, we break and we close the file. So what is left to do now is just printing or whatever processing you want to do. Here I've decided to try and split the header into code and name. If you look at the header here, the session code is roughly this bit and the name is roughly that bit. So I just split that string on this pipe character and print the code and the name separately, and then we can print the protein sequence and print the number of residues, which would be the length of the sequence. And there we go.